about the view. Remember, this is a different view. All of the views from this point, literally your booklet could be on your desk and it mimics the cross section. This is the one that actually mimics the board. Right? You're looking at that triangle that represents your scapula literally as it would be a scapula, but I just can't draw. Right? And we're looking at muscles that are going to be pulling up, muscles that are going to be pulling down, muscles that are going to be pulling towards the spine, away from the spine, and then muscles that are going to be trying to spin in a direction of upward and downward rotation. Okay? Upward and downward rotation is kind of cool. The merry-go-round, in terms of the spin, actually happens around the spine of the scapula. So when it does this, it kind of takes this little track. So that's where the pin is. True, we did the pec minor, right? I taught you how the pec minor pulls down, it pulls forward, and it's trying to rotate the merry-go-round downward because its pull on the scapula is lateral. It's a lateral pull. So if this is where the axis of rotation is for upward and downward rotation, and our upward rotators are going to be trying to pull this way, our downward rotators are going to be pulling on this side of the teeter top. In other words, if the scapula goes up, the pectoralis spine on this side is going to be pulled down, downward rotation. Okay. Was that the only? Oh yeah, I promised you guys a fun day of serratus anterior action. Okay, I know you guys are still probably weren't able to get a lot of sleep last night in anticipation of the serratus anterior lecture. I get it. Yeah. Serratus anterior. First of all, the pictures are up on Moodle. I just didn't code it very well, so I just put shoulder, but it's really shoulder scapula. So they are up on there. But I'm going to pull up a better picture. 310. Thank you for spell suggestion. Here's a beauty. This is a beauty. All right, serratus anterior is a fascinating muscle. So you think about serrated edges on a knife. Like, in other words, a butter knife isn't serrated, but if you get into a steak knife, it has serrated edges, right? The little blades are serrated. So it's very similar. It's kind of serrated. If you think about a knife and the little pointy ends on the ribs would be the little points on the knife, right? So it just serrated, serratus, and anterior has anything to do with its origins, insertion, its pull. It's trying to draw the scapula forward. In fact, if you think about it, if these muscles, they're kind of like finger-like projection muscles, and they start on the ribs and they insert on the vertebral border. That's why I like this picture, because you see the dotted lines on that scapula? That's where that muscle is actually pulling. Now, you don't see it because it actually passes in between the scapula and the ribs. So it's like if the scapula was a piece of bread, it would be the meat in between the slices of bread. And when it pulls, because muscles only pull, it's literally trying to pull the scapula anterior. It's pulling in a direction of anterior movement of the scapula, and what do we call that? Protraction. So the first and obvious function of the serratus anterior is a protractor. Protractor of the scapula. Now, some of you, maybe many of you, maybe a few of you, have maybe heard about how some people have scapula winging in the back, where their scapula. Remember, that's not a true joint. It's just floating back there, and it's held together by suction cup negative pressure of the muscles. The cool thing about that little party trick that you may have seen people do is normally they do it with their non-dominant arm when they do the party trick. And for a couple reasons. One is you have a little bit more motion on your non-dominant arm in the back end. You can do this trick when you try to touch your fingers. Right? I'm left-handed, so like I get a lot more motion naturally have more I'm going to say it a bunch of different ways, but it means the same thing. You naturally have more innervation on your dominant arm than your non-dominant arm, just in your activities of daily living. In other words, if you ever play racket sports, guess what? You're innervating your dominant arm a lot more than your non-dominant arm. Cooking, cleaning, fixing, working, moving, there's a reason a fiddler crab has like one giant hand and one small hand. You just naturally have more innervation of your dominant arm serratus anterior. You're reaching forward to grab a drink. You're innervating one side that you're not innervating the other. Okay? So the serratus anterior of your dominant arm tends to be a lot more fatigue resistant, innervated, toned. I'm just saying the same things for different ways of saying the same concept. And so what happens is that if your dominant arm has more tone on its serratus anterior, then that means your serratus anterior has extra help to keep it flush against your thorax. That's all. So your non-dominant arm serratus anterior being more phasic, weaker, less innervated, that's why your non-dominant arm you tend to get more waning, because that muscle isn't keeping it flush. Okay? So protraction exercises where you're innervating the serratus anterior, trying to re-innervate mostly that non-dominant. Now, going on to secondary function of the serratus anterior. Serratus anterior, remember how I said the upward and downward rotation axis is along the spine of the scapula? Look how high up that is. Let's see if I have They ban laser pointers, which is actually a good thing, considering my two sons would totally try to shoot it in each other's eye. Look how high that is. So what I'm trying to get you to see is that 99.99% of that muscle is underneath the axis of rotation that would cause upward, downward rotation. Only a very small little piece of it is on the top. So wouldn't we say that a majority of that muscle is under the spine of the scapula? So what? What does that mean? Analogies. One analogy I like to look at is, I saw a Western one time, and this cowboy's riding through the town, and he passes a lasso on a bad guy, and the lasso falls to the guy's feet, and he pulls him forward, and the guy rotates. You literally sweep the feet under him and he rotates. So what's happening is, when the serratus anterior wants to be an upward rotator, we're going to recruit all of the fibers that are underneath the spine of the scapula, which is a majority of fibers, and those muscles are going to pull in this direction. Scapula, serratus anterior, all the fibers underneath the spine, and they want to pull in the direction of upward rotation. Now, why is it that sometimes it wants to upward rotate, other times it just wants to protract? Well, you have other muscles that would work with it to cancel out its upward rotation, like the pectoralis minor, because the pec minor is a downward rotator, so when you have the downward rotator pec minor working with the upward rotator serratus anterior, they can work together to just protract nice and smooth, or those superior fibers. But the point is that the serratus anterior is a very important upward scapular rotator. It's literally just like sweeping the leg. You're taking the scapula and you're pulling underneath the spine to want to spin it up like this. Okay? So, serratus anterior, let's look at its function on your circle. You see that it's pulling away from, this is how I put these relative to the circle. Muscles that are more medial to that, it's not, that's an axis. So muscles that are more on the inside, more medial, more closer to the spine are trying to pull the scapula to the spine. Muscles that are on the other side are trying to pull the scapula away from the spine. So that's how you see function there. The serratus anterior isn't trying to pull your scapula to, it's trying to pull your scapula away. And then you can see the rotation circle that it's trying to cause, watch. It's trying to cause upward rotation. So right, remember everything's referenced to the right, upward rotation. Okay. Now, I'm going to put a pin in that serratus anterior non-innervation thing so that way I can get back to a really cool concept of shoulder dominance. But let's do trapezius muscle. This is a cool muscle. This is a really cool muscle. This muscle was, I'm going to sound like I told you before. That's all right. When I was in undergraduate, I was fascinated with this muscle because I could not understand how it would work. Like, just, can you just make up your mind, dude? You're up, you're down, you're all over the place. Like, muscles to me had to kind of look like the bicep. But then when you see something like that, you know, like that makes no sense. Until Dr. George explained it to me when I was sitting right there, and it's like, oh, okay, maybe that does make sense. This is a fan-shaped muscle, right? So there's going to be different parts to it that when I saw it, all I saw was the difference. I just saw up, down, one's pulled up. But what I didn't stop to notice was, well, they have some similarities too. They have things that they're pulling in the same direction. It's not just different, okay? So the trapezius is a big fan-shaped muscle. And remember, why do we have fan-shaped muscles? Is to really hone in these combinational motions that obviously our scapula needs to have. The first and obvious function of the trapezius, all of the fibers are trying to pull the scapula to the spine. That should be real obvious, whether it's an upper or a lower or a middle. They're all trying to pull the scapula to the spine, which makes it a retractor, pulling in the direction of retraction. All the parts of the fan. Remember, fan-shaped muscles have to have something in common. What's really cool about the trapezius has two functions in common, and only one that's different from the upper and downward parts. That really freaked me out. So the first one that they have in common should be kind of obvious, retraction. Okay? Now, for the purposes of this class, we're pulling, we have these origins all along the spine here, but the insertions, you have some parts up here on the spine of the scapula, and then you have some insertions that run down here. And we have what we call a force couple. I've taught you about force couples before. Two different linear directional forces that are working together to try to spin something in the same direction. The example I gave to you in class is you have two people that are going to rotate the merry-go-round. You're not going to be on the same side. Someone's going to go on the other side, and they're going to supply a push force in the exact opposite linear direction, but both of you are trying to spin the merry-go-round the same. That's what's happening here. Okay? So what you have is that when it comes time to try to spin the merry-go-round, I'm going to use this chair as an example because it kind of looks like a scapula. If I were only to use one force to try to spin the chair, it would give a little rotation, but it wouldn't spin optimally. You kind of have some translation involved. But if I really wanted to spin this chair optimal, I would give a force this way in combination with a force that way. Okay? Now, if we localize it a little bit more to this example, what's happening here is, to spin the chair, you have upper fibers, and some textbooks list them in numbers. They'll have like track 1, 2, 3, and 4. I like to look at it as the upper fibers are trying to spin by rotating this way, and the lower fibers are trying to force couple by spinning that way. The middle ones that are just pulled across, they may or may not have a spin depending on the repositioning of the scapula. But you can't go wrong by saying anything that's on top that's trying to rotate it is trying to spin it the same way as anything on the bottom that's trying to rotate it. So all of those fibers, heck, even the ones that are pulling to the side, as the scapula goes across, they have more mechanical angle of pull to pull in the direction of upward rotation. So really it's kind of all over. But here's the magic. Upper fibers are trying to do this, and lower fibers are trying to do the same exact thing. I'll do it again. Imagine a string on my fifth knuckle. And now imagine a string on my first knuckle. It's the same rotational pull. It's not the same translational pull, but it's the same rotational pull. Okay? So all the fibers of the trapezius, retractors and upward rotators in terms of pulling in the directions here. So what do they have that's different being a fan-shaped muscle? Well, the upper fibers pull in the direction of elevation and the lower fibers pull in the direction of depression. So let's look at this darn circle. And we want to connect the dots. I'm going to let you do it in your own unique way. Maybe some of you use colored pencils. Maybe some of you use highlighters. But upper trap and lower trap are the same, they're parts of the same fan-shaped muscle. The reason I split them on the circle was just for function. To show you that both of them pull in the direction of retraction. So you just have to connect them to say, well, that's just the trapezius. The upper trap and the lower trap is the trap. The upper fibers have an elevation component, the lower fibers have a depression component, but all the parts have an upward rotation. So again, that's pretty cool. You look at this freaky muscle and you're like, what, how in the world does that even do anything? And the irony is that two of its three functions, all the fibers pull in the same direction. That's really cool. Now, one cool thing I want to teach you guys today, I try to make sense of some of this stuff to give you some some useful information that you can take home and be useful in your life. Upward rotators, main upward rotators, serratus anterior trapezius. If you are doing an upright row or a shoulder press, now when I was growing up, I was left-handed, so my left arm was a lot. I literally looked like a fiddler crab. And when we were first starting the bench press, it would be like this. But over time, you know darn well, even though one shoulder might be stronger than the other, when you're doing your lifts, that force is balanced. Because if it wasn't, so whatever's happening there is supplying the same amount of force on one side or the other because you've learned to do so that the bar comes up linearly and doesn't tilt. Here's the cool part. Your non-dominant serratus anterior is a lot more atrophied, less innervated, fatigable, however you want to put it, than your trapezius. Because a lot of times when you carry things and when you're lifted, you use both hands to carry things and move things. It's kind of that forward, back, dexterous things that only happen unilaterally. So when it comes to upward rotators of the scapula, when I need to use upward rotators to press, to row, to lift, and my serratus anterior on my non-dominant arm just can't contribute as much as the other, something's got to make up for that work. Something has to compensate for that lessened serratus anterior. And it's that. It's your trap. Your non-dominant arm's trap contributes more to the upward rotation of the scapula. And how that manifests itself is the illusion that your dominant arm hangs lower than your non-dominant arm. It's really cool. It's a cool party trick too, because you can pick out lefties, because they're only 10% of the population. You're left-handed, like wizard. But this is why. It's not that it literally hangs lower. It's that your non-dominant arm's trapezius is more developed than your dominant arm's trapezius. Because it's had to compensate over time as a scapular rotator. It's had to do more work in order to match the forces on each side. So when it looks like someone's shoulder is lower, it's an illusion caused by the non-dominant trapezius being more developed because the non-dominant serratus anterior is less developed. It's just kind of a cool little so what about some of this stuff. Like it always cracks me up. Like you see these pictures and these illustrations and everything's so symmetrical. We are not symmetrical, man. We are mutants. Like, there's nothing symmetrical about us. Some of you have muscles other people don't have. Some of you have legs that are a little longer, shorter, ears a little higher, longer. Like, that symmetrical and perfect doesn't exist. It shouldn't exist. That's what makes us cool.